Hello students, here in this video we are going to study about the ramp type of digital voltmeter. In this video we will study the basic principle, working and diagram of this ramp type digital voltmeter. So let us start with the topic. Digital voltmeters are those devices which are used to measure the AC and DC voltages between 2 points. Okay, so we can say that they measure the potential difference between the 2 points. Now, digital voltmeters, they are of various types like ramp type digital voltmeter, integrating type digital voltmeter, potentiometric type, successive approximation type digital voltmeter. So here we are studying about the ramp type of digital voltmeter. This digital voltmeter, it is called ramp type because it is using a ramp signal for the measurement of the unknown voltage. So let us see first the basic principle of measurement in this ramp type digital voltmeter. So the basic principle of working of this ramp type DVM is that here we are using a linear ramp signal. So the time taken by the linear ramp signal to fall from a value or to fall from a voltage to the value equal to the input voltage or to decrease from the level of the input voltage to the 0 volts. Suppose here we are having a voltage. Here we are having a voltage level. This is our input voltage. And this is the line for 0 volts. So the time taken by a linear ramp to rise from a voltage to the level of the input voltage or to decrease from the level of the input voltage to the 0 volts. So suppose here we are having a ramp signal. So the time taken by this ramp signal to decrease to the level of the input voltage or the time taken by the ramp signal to decrease from the input voltage to the 0 volts. So first we are measuring this time interval also, and time taken by this to rise from the input voltage level to the voltage here. So by measuring this time interval, either this time interval or this time interval, if we are measuring this time interval, we can get the value of this unknown input voltage. Okay, so here we are using the linear ramp signal and we are measuring the time interval. Now let us understand this principle of working of this ramp type DVM with the help of a diagram, so it will be clear to us. So here we are having a ramp signal. The range of this ramp signal is from plus 12 volts to minus 12 volts. It is the range. We can use a positive going ramp also and a negative going ramp also. Now here we are having a negative going ramp. Okay. Now this black line, it is showing the voltage which we want to measure. Okay, this voltage is between the range from 0 to 12 volts. Now this ramp is being started decreasing. So this is the first coincidence point where the linear ramp voltage is equal to the voltage which we want to measure. So at this first coincidence, when the linear ramp voltage is equal to the unknown voltage, we are using a gate, and this gate is going to open at this first coincidence point. Now when this gate is open, the clock pulses from the clock oscillator, they are allowed to pass through the counter. Counter is going to count the number of pulses which are passing through it. Now after this first coincidence, again the linear ramp is decreasing and it comes to a point when it is equal to the zero voltage line. So when this linear ramp voltage is equal to 0 volts, that is the second coincidence point, then the gate is closed. Okay, so this time interval between the opening and closing of the gate, the number of pulses which have passed through the counter, they are equal to the voltage or the unknown voltage which we want to measure. So by measuring this time interval, we are measuring the unknown voltage and we are using a linear ramp for that. So that is why it is called a ramp type digital voltmeter. Now this time interval, it is measured by an electronic time interval counter, and the number of pulses which have passed through it, they will be displayed on the counter. Okay, we are having a digital display. Counter is counting these number of pulses, so that digital display is going to give us the readout value or the numerical value of these number of pulses. Okay, this is the gating interval time, means on and off period are there. This is the off period when the gate is not working, and this is the time interval when the gate is open and it is working for that. Okay, so this is the diagram which is explaining the basic principle of working behind the ramp type DVM. Now let us see the block diagram of the ramp type of digital voltmeter. So this is the block diagram of the ramp type of digital voltmeter. The various blocks in this block diagram are: here we will apply the input voltage. This input voltage is first attenuator and it is bring up to the particular range which we are using for the linear ramp. So ranging and attenuator circuits are used here. Then this input voltage is applied to the input comparator. Now here we are having the ramp generator, which is going to provide the ramp signal. So ramp signal and the input voltage signal, they are compared in this input comparator. When these two are equal, then a start pulse is given to the gate. So gate will be open at that time, and at that time the clock oscillator, which is generating the clock pulses, like this. So these clock pulses will be allowed to pass through the gate, and then they will be applied to the counter. Counter is going to count the number of pulses, and then here the ramp signal is again provided to the ground comparator. Ground comparator is going to compare it with the zero voltage. Here we are having the 0 volts. So when this ramp signal is decreasing, and when it is decreasing up to the level of the 0 volts, so at that time the stop pulse is given to the gate. Gate is going to be closed. So for that time period between the start pulse and the stop pulse, the number of pulses which have passed through the gate and counted by the counter, they will be displayed over the readout digital display device. So this is the block diagram showing you all the various blocks which are used in the RAM type DVM. So now let us see the working of this RAM type digital voltmeter, how stepwise it is working and calculating the value of the unknown voltage. Now here we have seen that it is basically using a linear ramp signal, and this linear ramp signal, it can be a positive going ramp or it can be a negative going ramp. Positive going means it is increasing from 0 to a particular level, and negative going ramp means it is decreasing up to a 0 level. Okay, this is positive going, this is negative going. Now this ramp signal, the range of the ramp, now the measurement will start. At the start of the measurement, the input voltage, it is going to be applied to one input of the input comparator. Another input to the input comparator is the linear ramp signal, which is generated by the ramp generator. So input comparator is having two inputs. One is the input signal and second is the linear ramp signal. Okay. Now when both these signals are equal, the input comparator is going to generate the start pulse and provide it to the gate circuit. Okay. Now in the diagram you can see that we are using two comparators, input comparator and a ground comparator. Input comparator is used to provide the start pulse and ground comparator is used to provide the stop pulse to the gate circuit. So you can see here that this gate, we are using two comparators, input comparator and ground comparator. Input is providing the start pulse and ground comparator is providing the stop pulse. as we are using here, you can see that in the working principle we have used a negative going ramp. So when this negative going ramp is equal to the input voltage, the input comparator, it is going to generate the pulse, and this pulse is provided to the gate. Now this gate is connected with the oscillator. This clock oscillator is providing the clock pulses to the gate. This gate is open, so these clock pulses, they pass through the gate and they are provided to the counter. Counter is going to start the counting, and it is going to count the number of pulses which are passing through it. So this is how the negative going ramp, when it is equal to the input voltage, start pulse is generated and it is going to open the gate. Now oscillator is driving the counter. So counter, as soon as this gate is open, the clock pulses which are generated by the oscillator, they are received by the counter, and the counter starts its counting. Now the same negative going ramp which is generated by the ramp generator, that same ramp is provided to the ground comparator also. You can see here ramp generator is providing the ramp signal to the input comparator also and to the ground comparator also. So when this negative going ramp is equal to the 0 volts, here input comparator was working and here the ground comparator will work. When this negative going ramp is equal to the 0 volts, then this ground comparator is going to provide the stop pulse to the gate, due to which the gate closes. So when this gate is closed, the number of the pulses which are generated by the oscillator, they will not be allowed to pass through the gate, and then they will not be counted by the counter. So the time interval between the start pulse and the stop pulse, between that time interval, the number of pulses which have passed and which are being counted by the counter, that number will be displayed over the digital readout device. So this definite number of pulses which are counted by the counter during the start and the stop pulse period time, during that time interval, that will be a measure of the input voltage. And this input voltage is displayed by the digital readout. So you can see that the input voltage, we are getting the digital reading of that input voltage. So it's a digital voltmeter. Okay, and here we are using a ramp signal by and comparing that ramp signal with the input voltage we are using. So that is why this voltmeter is known as the ramp type digital voltmeter. Now in the block diagram you have seen that there is a sample rate multi-vibrator also. So what is the use of this sample rate multi-vibrator? This multi-vibrator, it determines the rate at which the measurement cycles are initiated. That at how many at what time interval these measurements, that whether the ramp voltage is equal to input or ramp voltage is equal to 0 volt, at what rate these measurement cycles are being done. Now, how this rate is determined by this multi-vibrator? The oscillation of this multi-vibrator. Now, the use of this sample rate multi-vibrator, as I have said, that it is used to determine the rate at which the measurement cycles are done. So, the oscillation of this multi-vibrator, it is decided by the front panel control. On the front panel of this ramp type digital voltmeter, we are having a knob which is called the rate. So this front panel control is going to determine or adjust the oscillation of the multi-vibrator. This oscillation, it can vary from few cycles per second to 1000 or more cycles per second. Okay, so you can see that the rate of measurement is decided by this multi-vibrator. Now this sample rate multi-vibrator, you can see in the block diagram, it is connected to the ramp generator also and to the counter also. So to the ramp generator, if suppose that one time the ramp signal is being generated by the ramp generator, comparison has been done and the value of the input signal is being shown on the readout. Now for the second measurement, we want the next ramp signal to be generated. So that initiation of the ramp generator is done by the sample rate multi-vibrator. So this multi-vibrator, it provides an initiating pulse to the ramp generator to start its next ramp voltage. Okay. Now at the same time, it is also connected with the counter. So when the next ramp signal is generated, at the same time the counter has to be reset, because earlier the counter is showing the results for the first measurement. Now for second measurement, again the counter has to be initialized from the 0 value. So a reset pulse is given to the counter so that the counter is initialized again by the 0 value and the next measurement can start. So at the same time, when it is initiating the ramp generator for the generation of the next ramp signal, at the same time the reset pulse is also given to the counter. So it is giving the initiating pulse also and it is giving the reset pulse also to the counter, so that it is reset again to the 0. So that is the use of the sample rate multi-vibrator in the ramp type DVM. So we have studied the functions and the working of the ramp type DVM by using this block diagram. So in this video we studied that how this ramp type digital voltmeter is used to measure the value of the unknown voltage by comparing it with the linear ramp signal. Okay, whenever the linear ramp signal is equal to input voltage, a start pulse is given to the gate, and when this ramp signal is equal to the 0 volts, then a stop pulse is given. So we are measuring the time interval, and in that time interval the number of pulses will be equal to the value of the unknown voltage. So I hope that this topic, ramp type digital voltmeter, it is now clear to you. Thank you.